Today, in this last session, we have Dr. Mani Madhukar from IBM who will be telling us about the topic Hyperledger. Now, before he begins, let me introduce him to all of you. He is a part of Global University Program Team under IBM Research and is passionate about learning and sharing knowledge about the work areas that includes academic program management, cloud pre-sales, cloud application development, electronic content, etc. In his previous roles at IBM, he has worked across different technologies, including the cloud, obviously the blockchain, IoT, data science, DevOps, and IBM Watson. He has contributed to ecosystem development with stakeholders from ISVs, startups, and academia. He represents IBM in various forums as technical expert and panelist on various technology areas to few incubation centers, etc. So I welcome Dr. Mani Madhukar today so that he can enlighten us all on the Hyperledger. Thank you. So the time is yours.
Sure, thank you, ma'am. And good afternoon, everyone. It's really a pleasure to be part of this program today. Now, I've already seen, right, this is the last session of the entire FDP. So I'm sure it must be, it won't be really tiring as well. You know, it's somewhat like towards the conclusion. So people, either they may look forward to it like as a closure, oh, fine, finally we are the last session. And sometimes, right, the onus of the speaker on this speaker becomes a bit too more because he is closing. So if the 5 days had been a good experience for people, you should definitely try to close it up on a high. So, there is an added sort of a pressure on the speaker. But given the journey that you had done in last 5 days, I'm sure you have had a great learning from a blockchain point of view. Because when I was going through the agenda, I saw a good broad sort of a coverage in terms of topics being covered. So by now, I'm sure you must be familiar with blockchain, what it is. You would be good about what is cryptocurrencies versus what is Bitcoin versus what is sort of other applications of blockchain. And you would also be familiar with multiple platforms for blockchain. Like I saw you had already gone through Remix, you've gone through multi-chain, you've gone through Solidarity, I guess, right? So there is a good broad coverage of as far as the understanding or the knowledge imparted is concerned. So why did we keep this topic? Why did the coordinators keep this topic towards the end? Let me sort of start, and we'll try to end there as well. So far, whatever topics you would have covered from a blockchain point of view were aimed at one, how do you interpret blockchain as a technology? It was one piece that you would have known by now. Two, what is the first successful implementation of blockchain technology, which is cryptocurrency, is Bitcoin, which you've already understood so far, and which is actually a good thing. Third, you already have a good hands-on expertise so far, already have it in terms of how do you write smart contracts using Solidity or Remix, all those. So you have that basic understanding. Now let's try to see the other implementation where blockchain as a technology is so much in demand, right? And that's where Hyperledger will sort of come in. Now, before I go into Hyperledger and give you more about that, I'll not focus more about this because you already would have gone through. But then, so far, you would have gone through one aspect of blockchain applications or implementations. Today, my focus about discussing blockchain is blockchain for enterprise. How is blockchain as a technology being implemented in enterprise? And I'm not going to talk about Bitcoin, cryptocurrencies in any way, right? So my entire focus of discussion stays on blockchain for enterprise. Now, when I say blockchain for enterprise, what I mean to say is I'm talking about private permissioned blockchain. I'm not talking about public permissionless blockchain. my entire discussion today is going to be focused on private permissioned blockchain, right? So let's come back, right, and let's get started. So organizations, enterprises who have been doing businesses with each other have been looking, towards blockchain with a lot of hope in terms of adoption, because what blockchain brings to the table, no other technology brings to the table, right? There can be so many other synonymous technologies which can be used instead of blockchain, but the amount of trust, but the amount of transparency, or the amount of compliance which blockchain brings to the table, it doesn't have any other parallel. That's the reason organizations, enterprises are looking for blockchain big time, and that's the reason blockchain for businesses is very, very highly rated today. And almost all the organizations are trying to figure out how do they use blockchain, where do they use blockchain in some way or the other. Okay, so having said that, organizations cannot have a public permissionless blockchain. Why? Because you can't do business with anybody and everybody. You normally do business with people whom you know, right? So in a business, you would have a business partner. You would know whom you are going to do, a transaction with. Party A has to do some transaction with party B or party C. So this A, B, C, D cannot be anonymous, right? Be actually anonymous where they do not actually understand, that A, B, C don't have any identities. It is just not possible, right? So it's really imperative that they have some identity. So that's why we say participants with identity are the ones that they are considering in a private permissioned blockchain. Okay, good. So as you would have understood that these transactions in a business world are driven through some contract. Contract is a document of understanding. What is a document of understanding? So again, this is a contract, right? Mani Madhukar is supposed to log in at 2 o'clock in this as a part of this session and deliver something, right? This is an underlying contract, right? This is something which governs the transaction between me and the coordinator of the FDP, right? And so is with any business deal, right? You buy something, you make a payment against that. You subscribe to a service, you basically make a payment or you do something against that. So that's what is basically contract, right? And all the transactions basically are governed by these contracts. And whatever you do as a transaction actually gets recorded. Means you store something, that information somewhere. That's what is a ledger. So transaction is actually recorded in a ledger, and that's the basic premise of blockchain, right? Blockchain for enterprise has 4 things to basically talk about. It's driven on consensus. It has a provenance built in. It has immutability, and it talks about finality, right? These are the 4 key tenets of blockchain when you talk about from an enterprise point of view. Okay, so I'll not harp on this much more, but then we'll go further from here. And I understand that you already have gone through 5 days, so you would have that basic knowledge about it. So today we're going to talk about Hyperledger as a platform. Why Hyperledger as a platform? This is where I'm coming to. All this introduction that I was trying to create leads us to this. Now, when an enterprise needs to adopt to a blockchain, and we are saying that blockchain is a technology for maybe next century, that means this technology should be open source, number 1. Number 2, it should be open standards based. Number 3, there should be an open governance model to this technology. Number 4, there should be no vendor lock-in. Why? Because if an organization subscribe to a blockchain platform and they get stuck with that platform and they cannot move out of the platform at their will, that is basically a vendor lock-in, right? No organization can afford to do that. If I'm talking about a technology which will sustain for next say 50, 60, 100 years, where blockchain is actually bringing us to, then there is no scope of vendor lock-in. And hence, the technology or the platform has to be open standards, open source, open governance based completely in all true senses. Otherwise, this is happening, enterprises will not adopt to this technology. And that's where Hyperledger fits in very well, right? So Hyperledger is an umbrella framework under Linux Foundation, under which there are multiple projects, right? There are so many tens of projects in the Hyperledger. Today, we are going to focus about something called as Hyperledger Fabric in my talk. But then before that, let's understand what is Hyperledger, right? So founded in February 2016, so it's not very old for that matter. This was a product of a hackathon which happened in one of those stock exchanges in New York, right? long time back. And if you see this infograph, which is updated to almost September 2020, you'll find a lot of companies which are on board this project. There are premier partners, there are associate partners, there are academia associates as well. You talk about UCLA, you talk about Yale, you talk about KBA, they're all there. And of course, the big companies like Accenture, Airbus, MX, Fujitsu, DTCC, Intel, IBM, JP Morgan, they're all there. They're all there. So the reason why all of them are there is because they understand, and that's the reason Hyperledger is so much more, being accepted in the market, right? Because it so much suits to industry point of view, enterprise point of view. It's very much pluggable. So you don't like a, consensus mechanism, pull that out, pull something in, something else in, right? That's much modular structure that the Hyperledger has. Okay, yeah, so what are the key features of this? Because this is very important. It provides for a shared ledger, and the smart contracts here are called as chain code. It has a mechanism of privacy and permissioning through something called as membership services. These membership services can be within the network, or they can be third party as well, depending upon the understanding of the network partners. And I said already, it has a very modular architecture and it has very flexible hosting options. Why so? Because unless you provide this sort of environment to the enterprise, they will not buy into this technology, which is supposed to be going for so many long period of time, right? And that's the reason why Fabric is in demand as far as enterprise adoption is concerned. Let's try to understand the roadmap, what we have traveled so far. Where are we going with the Fabric thing, with the Hyperledger Fabric? So we had the first version released sometime in 2017, guys, version 1.0, which was based upon PBFT, practical Byzantine. It was version 0.6, which was based on PBFT, practical Byzantine's fault tolerance method, which was ideal for 4-node architecture. But then, we had to scale from there. You cannot have a 4-node architecture from a blockchain adoption point of view. Enterprises have got hundreds of nodes to connect to, right? And that's where, to make it more scalable, the current Fabric is, architecture 1.0 is really, very effective, very, efficient that way. We will get into that in a while for now. Right now, what we have is, we basically have a 2.2, version already, in production. Which has a lot of flexibility in terms of adoption. Okay, by the way, I was talking about Hyperledger Fabric so far, guys. Okay, this is basically the roadmap for the Fabric which we had so far. Next is this info, which basically talks about something called as IBM blockchain platform. We call this as IBP. Now, IBM Cloud offers blockchain as a service, so that you do not have to bother about. Okay, before that, let's understand. Blockchain application typically comprises of two components. Okay, one is the underlying connectivity, which basically binds all the network participants. That's one thing. And two, the smart contract or the chain code, which resides on top of these nodes and connects all of them together, so that whenever there is a transaction happening, the transaction is updated on the almost real time across all the nodes. Right. So having said that, so two major components: one, the underlying network connectivity, and two, the smart contract or the chain code. Now, IBM on IBM Cloud provides blockchain as a service, and the same is offered as service across AWS also, and other cloud vendors also do that. Now, what does this service provide you? This service actually takes away the complexity of implementation of a blockchain solution, right? And for that matter, the entire managed platform, which is blockchain as a service, provides you for two components. Again, the underlying network connectivity, which can be on IBM Cloud or any other cloud or even on-prem, and you can integrate all of them together. And it provides for an easy deployment of a smart contract or chain code across these nodes, these peers that you create, whatever, on cloud, IBM Cloud, on-prem, wherever you want to, right? So IBM blockchain service is basically that offering. But under the hood, if you ask me, it is powered by Hyperledger Fabric. So IBM blockchain platform is powered by Hyperledger Fabric, right? And why so? Because of the contributors, we are one of the premier partners to Hyperledger project, under Linux Foundation, right? If you see there, IBM is there. So we have been the early contributing Hyperledger Fabric to that effect, right? So this is all about the roadmap for blockchain platform, both from IBM as well as the go further into it and try more about it. This is the typical Hyperledger Fabric architecture, right, which has a couple of components. We'll try to dissect this and try to understand more about it, right? So there is a client application which is built using an SDK. There are multiple SDKs available for Hyperledger Fabric, including the Node, including Python, including Java, including Golang, that's which the Fabric is written into. So all those SDKs are made available using which one can develop a client application. As I was telling a while back, the certificate authority, the CA, the membership service, right? So there is an external CA, which is basically optional, as I said, and there is a membership service, which is built in within the framework as well. So depending upon the requirement, the blockchain system can either have an inbuilt membership service or an external CA. CA is certificate authority, okay? Okay. Then we have a couple of types of peers, guys, right? So we have an endorser, we have a committer. We'll just see about these in a while, right? And we also have something called as an ordering service. The O's that you see, the green ones, those are basically the ordering service, okay? So this is a basic broad Hyperledger Fabric architecture, which has, an SDK, which has a membership service, which has peers, couple of types of peers, and an ordering service to that effect, okay? Let's dig into it further to understand how does the application talk to the ledger. So as we just talked about, there is a client application built upon the SDK, which basically talks to the smart contract. Hyperledger has two data stores, right? Two data structures. One that is called the world state and the other that is called a blockchain. So we'll just understand that in a while. But for now, just try to assimilate that it has got two data structures. One is called world state, the other is called a blockchain. So what happens is the client application basically talks to the smart contract, for two things. One, it wants to update a particular transaction, and second, it wants to retrieve or it wants to put something there, right? Okay. So what happens is, as you know, the blockchain is basically a sort of a linked list, which is blocks tied to each other, right? The hash of the previous block is used to encrypt the next block, and then the hash of this block is used to encrypt the next block, and so on, right? So it's like a very tight linked list wherein you cannot play with any block, because the moment you try to sort of change even a single bit in a block, the hash changes. At the moment the hash changes, the entire blockchain gets nullified. Okay, that's one data structure. The other data structure we talked about is the world state. So world state is a data store where there is the current value of the asset is stored. Okay, so let's say there is a variable x. Okay, and this x current value is equal to 10. And we did a business process to update the value of x from 10 to 20. Okay, so the moment the value of x is, so the current value of x is equal to 10 is reflected where? In the world state. Okay, the moment you update the value of x is equal to 10 to 20, so that 20 value is updated in the world state, that is the current value, and the historical value of x is equal to 10, which was previously there, actually gets recorded in a blockchain in form of a block or as a part of a block in some way, right? So world state is the one which has the current state of the asset, and hence get, put, and delete can be worked on that. Whereas the blockchain is where the historical information or the historical data is stored, and you cannot delete, you cannot edit anything which is a part of blockchain, right? So that's what is the two different data structures and how they are different. This is the example for the two. Okay, so Fabric, as I was telling, the Fabric structure is basically maintained by each peer, and each peer includes two things: a blockchain and a world state, right? So typically, the world state has all the information that a blockchain would have, right? Though they are separate data stores. So what happens here is, we'll see that in a while, but from here, just try to understand the basic zeroth block we call as Genesis block, and then we have all these block 1, block 2, block 3, and each block is basically encrypted using the hash of the previous block, and hence that is what is the blockchain part. And the world state we already discussed, right? A world state typically is from a fabric point of view, either it is a level DB or a couch DB, right? And basically, it's again a key value pair data store, which can also store documents, and it also allows complex queries. So either a level DB or a couch DB, okay? And all the channel configurations are written in this Genesis block, right? That's where there is the parent block of any blockchain. Okay, so let me go further, right? And let's try to understand what are these various types of nodes and peers and all that stuff, right? So typically, three types of nodes or peers we have. One, something which maintains the ledger and the state, right? We call them endorser, and we call them a committer, right? So our endorser is something which basically endorses a transaction based upon certain, smart contract. Committer is something which basically can write to the data, write to the world state or the blockchain, and they maintain the ledger as well, right? So that's what we are talking about, right? Those are called a peer, and they must hold a smart contract to endorse. That's one piece. Second thing is ordering node, right? Which basically approve the inclusion of a particular transaction into a block and a ledger and communicates with the communication nodes. We'll see that in a while, so don't worry. I'm just trying to explain the role of the various nodes here. And third is the certificate authority, which basically issues digital certificates to member organizations. So it basically issues two types of certificates, T-certs and I-certs, right? I-cert is the identity certificate. It issues to all the participating participants in a business network. Those, user A, user B, user C, it basically provides them with the identity certificate. And second is the transaction certificate. Each time these A, B, C, D users are trying to do anything on a blockchain network, either trying to query it or trying to read or trying to write, they are basically provided with something called as T-cert, transaction certificates. Transaction certificates are like one-time keys which exhaust after single use, right? So you cannot use them second time, right? The moment you use them once, they're all gone, right? It's like a one-time prepaid card. The moment you swap it, the card is invalid, of no use further. Okay, now how do we achieve consensus, from a fabric point of view? So in a fabric, the consensus is achieved using this, transaction flow, using an orderer mechanism where we have something called as Apache Kafka. We have an endorse, order, validate transaction flow, right? We'll see that also in detail when we see the exact simulation of how a transaction happens in a fabric. So endorse, order, and validate, right? Three basic steps which are used to achieve consensus in a Hyperledger fabric scenario. So this is the important part, guys, where you will get a complete picture, like how does a solution, how does an application talk, and how does a simple transaction happens in a blockchain network using Hyperledger fabric. Okay, let's try to understand this infograph first, right? So there is a client application developed using some SDK. Then there are E0, E1, E2, which are the endorser nodes. And these nodes have a ledger. If you see there in the blue, there is a ledger there. These E0, E1, E2 are running two smart contracts, smart contract A and smart contract B. A smart contract A is one for one business process, and smart contract B is for some other business process. For example, so for incrementing a variable's value, there is a smart contract A. For decrementing a variable's value, there is a smart contract B. This is a very crude example just to explain what the smart contract is doing, right? The business logic or the business purpose that is trying to serve here. Okay. Then we have P3 and P4, which are basically the committer nodes, right? And if you see P3, P4 again have their own ledger, and they again are running a smart contract A and a smart contract D. So there is a business process, let's say increment of business process. So the same smart contract is running on committer node, but the code is different. Similarly, there is some other business process D. So let's say this D is for importing some new variable, right? So there is another business process D for that, which is residing on committer P3 and P4. Then there is a high availability ordering service. In this case, you see a 5-node ordering service, which is a HA service here, right? HA means high availability. It's fail safe. So even if certain node fails, you have a completely foolproof mechanism of ordering service. Okay. So a client application sends a request, sends a transaction proposal to endorser E0, E1, E2, which has a smart contract A for incrementing a variable X. Okay, good. What next? So after the endorsement, after the proposed transaction comes to E0, E1, E2, E0, E1, E2 actually simulate the transaction, the execution of the transaction, and it basically captures the read-write set, RW set for this transaction which has been submitted by the client application. Okay, and once, and I'm saying simulation, I'm not saying they write to the ledger. Okay, so they basically do this execution simulation for capturing the read-write sets. Okay, once they have got the read-write sets, what they do is they basically send this transaction back to the client application using a signing process, and these RW sets are signed by each endorser individually along with something called as a version number. So let me explain this point here. This is important. So let's say variable X is current value is equal to 10, and the client application is saying that I want to update the value of X is equal to 10 to X is equal to 20. And this is the third time I'm updating the value of X. So that means the version number is very important because it actually helps us in taking away or mitigating the risk of something called as double spend in a blockchain network. So X is equal to 10 is the current value, X is equal to 20 is the proposed value, and version number is equal to 3. Okay, so this RW set which will basically have the proposed value of X is equal to 20 and the version number of 3. So the historical version number was 3 and the new update is proposed. That means the new version number will be 4, right? Because it's the next update which is happening on previous version of 3. Now, it basically E0, E1, E2 provides all these certificates, endorsement certificates to the client application. The client application basically takes all these endorsement certificates, bundles it together, and actually forwards it to the ordering service. Now, if you see there, at some point in time, there will be multiple client applications submitting their transaction request to the ordering service. That is why you see all these red arrows coming from the bottom inside the ordering service, and the one that we are talking about coming from the left-hand side of the infograph, right? So this is how you're having. So it's like a funnel, right? Ordering service is more like a funnel, right? Where you have got a lot of transactions coming into the system, and ordering services basically providing them a sequence, putting them together so that they can be executed, right? So ordering service collects these transactions into those proposed blocks and forwards them to the committing peers. Okay, good. Now, what does this committing peer over here does? Okay. So the committing peer basically validates each transaction against the given RW sets which has been provided by the endorsement node to check whether the endorsement nodes provided RW read-write sets and the version number are still valid or not valid. Why I'm saying so, or why do they check this? Let's say right now it's 2:25 p.m. right? So when client application, or rather E0, E1 or E2, when they endorse the application, the time was 2:25 p.m. By the time this transaction came to P3, P4 through ordering service, let's say the time now is 2:32 p.m. That means 7 minutes have exhausted since endorser nodes have endorsed his application. Now, what may happen is, because we are talking about a very big network, this is only 2 which are showing indicative here. There can be tens and tens of committing peers here. Okay, multiple ordering service also possible. So let's say between 2:35 p.m. and 2:32 p.m., 2:25 and 2:32 p.m. between these 7 minutes, another request from some other source, another request from some, you see the bottom red ones coming in, another request from some other application has again come in for the same X variable, and the value of X is already updated from 10 to 15 by some other process. Maybe possible, right? Which might have started early compared to our client application. So that means by the time it comes to the P3, the client, the RW sets which are enclosed in the endorsement certificate are no longer valid. Why they are no longer valid? Because it was talking that X is equal to 10 and proposed value is 20 and version number is 3, proposed to be 4. But the already which, if you see the ledger is already updated with X is equal to 15 and maybe version is already updated there as 4, right? What means is some other node, some other ordering service, some other committing peer has already updated the variable X, and hence these RW sets are no longer valid for this current world state. So such invalid transactions are retained, but then they're not updated on the world state. Let's go to the other side of that transaction. Let's say these RW sets are still valid, which came along with this E0, E1, E2 validation endorsements. If that is the case, then P3, P4 will validate those transactions based upon the smart contract A for that business process and then update the world state. And once they actually update the world state, the transactions are updated in almost real time in all the copies of the ledger which are there on the blockchain network. This is typically a transaction process which happens from a fabric point of view, right? And once the applications, once this updation happens, all the PLs are notified about the updation of the transaction. Okay, so this is in totality how a transaction takes place in a blockchain-based network from a Hyperledger point of view. So if you have any questions, you can please put it on chat. We'll come back to a Q&A in some time. Okay, so let me works in a network, how the transactions happen there, right? Let's talk about the ordering service here. So ordering service typically packages the transactions into a block which have to be given to the committer nodes, right? And all of this communication happening between these nodes is happening something called as a channel. We'll see that in a while what typically a channel is, right? This is all a crash fault tolerant consensus. We call it as raft consensus for the ordering service, and it needs minimum 3 nodes. Okay, why odd number of nodes are recommended? Because we are talking about a high availability system. By the way, there is something also called as no-ops. Okay, no-ops is basically something where there is no need of any consensus in a fabric scenario. So there are certain use cases where you do not need a consensus mechanism also. So there, in those cases, you don't need an ordering service for that matter, right? So you can always have a no-ops as a consensus mechanism there. Okay, let's try to understand the channels concept over here. What is channels? So if you remember those endorsement nodes E0, E1, or P0, P3, P4, whatever they were, they basically connect to each other using something called as a channel. Channels are very key to the Hyperledger Fabric concept because they provide privacy between different ledgers, right? So anything that E0 and E1 are talking on one channel is only and only private to E0 and E1. Nobody else gets to know what E0, E1 are talking between themselves. Similarly, what E0 is talking to the ordering service, it's entirely private between E0 and ordering service. There can be no other stakeholder. However, there can be channels where there are multiple more than 2 partners, 2 PLs there. So there can be a channel between E0, E1 and ordering service as well if the need be, right? Consider a real life example of there is an insurance company, there is a bank, there is a regulator, maybe some auditor, like that, and there may be some business network participants. So there would definitely be a basic channel between all the network participants. That's one piece. But the regulator and the insurer may have a separate channel between them, and whatever they transact on that channel will not be available, or it will only be private between those 2 participants. It will not be visible, because the scope of the ledger is local between that channel. It cannot be beyond the channel. Okay, so that's one piece. Chain code is typically installed on all these peers to access the world state, right? As I was telling earlier, world state is something which has the current value of the asset, and chain code is actually instantiated on specific channels where we actually want to sort of replicate and work with, right? And any peer can be a part of multiple channels, by the way, guys, right? Let me go back to this infograph and give you some more information here. Okay, so if you see this network, just a moment. If you see this network here, E0 can be endorser for a business process A and B. At the same time, E0 can also act as a committer for some business process X. So one peer can don multiple hats depending upon the requirement. It is not that the E0 can only be an endorser for A and B. It can be something else also. It can be a committer also. It can be something else also, right? Depending upon the smart contract that it is running for that specific business process. Similarly, all the communication happening between E0, E1, or between these, that is what we're talking about as channels, right? Which is the scope of, which is native to those participating nodes, right? That's what we are talking about here. So channels basically provide for privacy between different ledgers, different peers, whatever you want to. So there can be a single channel network where all peers are connected on a single network. In this case, this is depicted using a blue. So peers may have different chain codes, right? A, B, whatever it can be, right? But then they may be on a same system channel, right? So this is what a single channel network. Then there can be a multi-channel network as well, right? Where there are multiple channels existing between different partners, right? For example, there is a network channel between client application and E0, right? And there is a channel between E0 and ordering service. Whereas E1, E3, if you see E3 there, E3 is part of two channels, right? So it is also on the green one and also on the red one, right? So depending upon like that, right? A one peer can be a part of multiple channels as well. Okay. So what is this actually, this peer thing, right? And I'm sure by now you would have a fair understanding about, because you already have worked with Remix, you already have worked with multi-chain, and you have worked with Solidity as well. So you have a pretty understanding of what a peer is, right? You know, two chain codes which are running on that, right? And there is a local copy of the membership service provider which is running on this peer, which basically gives the peer its identity. We talked about ICERT there back there, right? Okay, so each peer can connect to one or multiple channels. We already talked about that, right? It basically manages one ledger per channel. So if this peer has three channels, green, red, and blue, that means this peer is actually having three ledgers, right? Peer is where we install the chain code. Okay, now how does this chain code is managed? It is basically managed in Docker containers for instantiated chain codes, right? So typically it is a Dockerized container for the chain code, right? So chain code is instantiated on particular channel. Green one, there will be different one, red one, it will be different, and the blue one will be different, right? And no state is actually stored in the container, by the way, right? Everything that we talk about of storage is stored on the ledger of the channel and nothing else, right? Each peer has a local copy of MSP, which basically provides the cryptographic content, as I said earlier, right? What the peer can access, what the peer cannot access, the ICERT and the TCERT, which the peer is basically provided for, that's basically through the membership service provider, right? And this, works by emitting events, right? Typically, like a database, you have those, triggers there. So here, there is a trigger to emit an event, right? So if you see there, so this peer is connected to the blockchain and the world state, and it has got separate blockchain and world state for all the three channels. See a blue one, a red one, and a green one, three separate ones. So single peer has access to or has stored three different world states, three different blockchains that's connected to three different channels, and it is running two chain codes, right? And it can be donning any hat. It can be a endorser, it can be a committer as well, right? So I hope the peer concept is clear, right? Now let's go and understand what is this client application we have been talking about, right? So the client application is developed using some fabric, some SDK, right? It SDK can be for, from a fabric point of view, it can be in Node.js, it can be Go, it can be Java, it can be Python, as we already talked about, right? Towards the start. And this client application basically connects to the peer using a channel, right? That's the reason all those green, blue, and red lines you see there, those are the channels, right? And it can connect to one or more than one orderer nodes, right? It can receive the events from various peers, and it has a local MSP copy of the membership service provider copy of that particular channel that it is connected to, so that it knows whom it can connect to it has that. So ICERT has all those details, right? Where it is sort of accessible, which channel can it access? All those details are provided through the MSP here. Okay, this is another good part, which is basically the certificate authority. We're talking about Fabric certificate authority this time, right? It's not a third-party certificate authority. So there is this, I was telling about this certificate authority provides for these E-certs, T-certs and all, right? Yeah, it basically provides for typically that using LDAP, using HSM, and high availability using typically for user authentication. Okay, so I'm not going to get into these pieces here because this is more about when you start a particular network, then what is the typical commands that you do. These are all those commands that how do you bootstrap the network, how do you install the chain code, how do you instantiate, create channels and all that. I'm sure you would have done all of this in the previous sessions using maybe the multi-chain or a Remix framework. Okay. This is important. I'll just cover this and then we can have a Q&A. Endorsement policies are really one of those very important parts of the entire system, which describes the typical conditions using which the transaction can be endorsed, right? So a transaction can only be considered valid if it has been endorsed according to the policy. Now, where is the policy residing? Policy is residing in the chain code. You remember those yellow boxes, squares, chain code for A versus process A, for business process B, and so on, right? So each chain code is deployed with the endorsement policy, which which typically is in two ways. One is endorsement system chain code, which has the response for the endorsing peer, right? And second is the validation system chain code, which basically validates all the endorsements which are coming, right? So again, the same mechanism of propose, execute, respond is basically used for an endorsing peer. So see that ESCC basically resides on a validation on a endorsing peer, where you have a chain code which talks to the endorsement system chain code. Once you have endorsed and you have sent the endorsement certificate to the committing peer using the mechanism of order and deliver. If you see, there is a ordering service sitting in between, right, which is basically for ordering and delivering. Once the ordering and delivered service has been delivered to the committing peer, then you have the validation system chain code, right? The A, which you saw there on the P3 and P4. So that is what is VSCC, which basically validates the endorsements done by the endorsement system chain code. Once the validation is complete, and validation is completed, the transaction is committed to the ledger. That's the entire closure of the overall cycle, right? Right from proposing to committing of a particular transaction. This is typically a syntax, not going into this. So I'll basically stop here. Look at the questions in case there are any on the chat. Cloud-based network, they can be either on a VPN, they can be in some way. The idea is they need to be connected underneath. That's one way, one thing. Second is all those nodes, right, which you are creating or you are connecting using these network, they need to have a chain code running depending upon what role are they going to play in the system. And now what goes into the chain code, you know pretty well, right? So you basically develop, okay, before you start writing the chain code, or before we actually start doing the business, guys, the rules of business are defined before you start doing the business. Now, how do you do that? Typically, the business network participants will, sit across the table and define the rules. Okay, there will be a 15 days of credit. Once the product is shipped, I will send this document. Once I've received the document, once I've received the product, I will release the 20% of the payment or 30% of the payment. So those are the logic. Those are the business rules, right? So you define those business rules and you actually agree to that. All parties agree to that. That is basically something like a scope of work document for a developer from a developer's point of view. So once you have a scope of work defined, then you start developing the solution, putting all those small pieces together in terms of authentication, in terms of membership service, in terms of how the various components are talking to each other, right? So all of that put together is when you really come up and you sort of create a solution there. Okay, I don't see any other question here. Yes, our government is using blockchain in multiple ways, not just the land record, but then there are multiple business multiple use cases which are already out in production, including banking and finance, including insurance sector, including land records, including this taxing system, the government tax that we have, way bills and all. A lot of places, the blockchain is already getting utilized. Okay, so that is something which we do not get to know because we don't need to know about that. So that's how it is. Any other folks, any other question that you would like to talk about, ask? A lot of learning content, free courses, and it is absolutely free for academia, right? Faculties, students, everybody, it's all free. All that you need to have is you need this, right? So today we are talking about, this is called as IBM Academic Initiative Platform. It's a global program under which we provide a lot of learning material only to academia. It's not open to anybody else, right? Because the software which are basically provided here are the same which are basically sold to the customers. So whatever is sold to the enterprise customer is basically provided free of cost here to academia to learn, right? Okay, so today we are talking about blockchain. So let me come to so here there are content across 9 technology areas: cloud, data science, security, quantum computing, system engineering, that is software engineering part is there, IBM Z, power systems, blockchain, and IBM Watson. But since today we're talking about blockchain, so let me go. No. Okay. In 4-5 tabs here. So one is resources, then there is software, courseware, badges, and careers, right? So the resources is something where you can actually, get learning content in a lot of ways. It's absolutely free of cost. You can download this document. The entire second, from here, you can even download the Fabric directly from Hyperledger.org as well. But then, since IBM uses Hyperledger Fabric, there's a download link. You can download it. It provides you with containerized, can be easily deployed on your either a Linux machine, or in case you're using a Mac machine, for Windows you can use Ubuntu, and then you can deploy it. There are a couple of courseware which are also available on this, right? So there is a blockchain essentials course available. There is a blockchain course for developers which is also available who wants to develop some application. There are a couple of digital badges also available which you can leverage. These are self-learning. You can get these badges, and even you can explore opportunities with IBM from this portal, right? So there is a link of career, right? So you can, just to show you, right? I'll just go to one more tab just to explain what more content is available. I'm going to data science tab here. Similarly, the content is structured on this tab also: resources, software, courseware. So in academia, typically we look for data sets big time, right? So Data Asset Exchange is a repository where we a lot of which can be downloaded for free from here. Similarly, there are a lot of these software which are available for without any charges, including iLog, Cplex, Watson Studio, SPSS Modeler Premium, Cognos Analytics. They're all without any charges, guys, right? You can download all of them there. And then along with that, there's some courseware which are associated, which can be downloaded from here. And then similarly, there are some, see these courses, you can actually download these courses. You can use yourself. You can even use it for teaching your students, whatever you want to do. And then there are badges associated as well. These are all digital badges which are available without any charges. Okay, so you can get these badges: Python for data science foundation for level advanced. These badges are there. I put a while back just to give you a glimpse about what all the links are there. It again gives you a lot of learning content, right? See this. This is the badge I was talking to you about. You get such sort of badges from this platform, which are again offered without any charges, which you can leverage. Okay. To do this further, I'll just share the link of it, on the chat. Somebody's asking. All that you need to know here is, guys, you need to have an institutional email ID to access. Okay. I'll show call provided email ID. That is how we control the assets which are made available over here. Okay, for example, if my at the rate gkv.ac.in, then college is already enrolled with IBM Academic Initiative. It basically lists the college name. I just have to select my role, whether I'm a teacher or a staff or a student, what department, what degree am I associated with. That's it. And once you are done that, once you click all these things there, I say I accept. So this is one way of doing it. There can be a case where your college may not be, sort of enrolled here. ekv.org. Okay, let me say submit. So it will come back and say that your college is not registered with Academic Initiative. In case you are from the college, please make a request. So you can typically request for adding your college right from here. Say, let's say I'm a faculty and I want to add this domain for academic access. I just have to complete this form and that's it. Once I do that, this request will come to IBM for getting the college added. Within 2 days, your college will be listed and then you can come back and you can register here to get the access to that. So I'll actually stop here and let me take the questions if there are any.
Such an informative session, and for agreeing to join in this FDP. Friends, let me tell you that Dr. Mani is a very devoted person and a very busy man also. So he agreed to join is really a pleasure for us, and it is always a good learning from him. I personally get motivation whenever I speak to him, and it was really feeling nice when I was hearing him today. So thank you, Mani, for joining.
Thank you, sir. It's a pleasure to be here. Thanks a lot.
Thank you.